Hey Algebra 2, here are the notes for 13.4 Law of Sines Day 1. So the other day we did a little different note sheet in class, but ultimately I thought this note sheet was maybe a little bit simpler to look at, so I'm going to fill this one out. So the area of a triangle is area equals 1/2 base times height. However, if we don't have the height of a triangle, say we have something that looks like this maybe, that's like a 2, 3, 5 triangle. If we don't have this height, we don't have h, it's really hard to be able to find the area of this triangle. So what we did in class the other day is we looked at this angle and we said, I know that the sine of this angle is equal to h, the height of my triangle, which I don't know, over my side length here. And I'll just write this as a general maybe a. So I'll rewrite that sine of my my angle B is equal to h over a. Now I can solve this so that I know what h is, and I know it's sine of B times a. Now if I take that back over to what I was just saying, one of the cool things I can do here is I can replace h with the piece of information I found. So I can now say that the area of a triangle is 1/2 the side length B times the sine, 1/2 B, let's write that out, let's fix that real quick, because we need to do both sides of the triangle. Got a little fast with that. 1/2 BC, so that's the length, I'm going to replace it with that, so BC times sine of A. So we have everything represented here, and I know that's a little hard to read. But essentially what this does is we can now find the area of any triangle even if we don't have the height. Even more importantly is if we need to solve for the missing sides and angles of a triangle, we can do that by using the law of sines. And the law of sines says the sine of A is proportional, or it is equal to sine of B over side B times sine of C over side C. So your top are angles, your bottom are sides. So let's see how we use that now. I'm going to go down here and I'm going to see what pair I have. What information do I already have so I can set up a completed fraction? Well, I see that the angle 55 pairs with the side length of 12. So sine of 55 over 12 is one triangle. Once I do that, then I can set up another one. Well, I have this angle of 45 and I know it pairs with A, so I can say sine of 45 over A. Now I can just cross multiply, and my little trick for this is I multiply across and then divide up, so sine 45 times 12 divided by sine of 55 gives me a side length for A, which is equal to 10.4. I'm going to round to 1 decimal. All right, we can do the exact same thing to find the length of B then. Well, kind of. We first have to find this angle. And we don't have to do law of sines or anything fancy. We just have to do 180 minus 45 minus 55 to see that the final angle is 80 degrees. I'm also going to label A while I'm up here, just so I know what I'm still looking for in my triangle. So now I can set out and say sine of 55. I always come back to that piece I know is true. I know that's a true pair. Equals sine of 80 over B. Again, I do sine 80 times 12 divided by sine 55. This is just a little shortcut. If you cross multiply, you'll find the exact same answer. And we find that B is equal to 14.4. No labels needed because no labels were given. And the same way that we can find side lengths, we can also use law of sines in order to find the the angle measures here. So I know the true pair is 75/3, so sine 75 over 3 is equal to sine of A over 2. And I can do this by doing 2 times sine of 75 divided by 3. But what I get is this. I get a 0.6439 yada yada. But this isn't my answer because that's only equal to sine of A. If I want to find A itself, I have to do second sine, second answer, to get my actual angle measure, which in this case, big A is going to be 40.1 degrees. That one I do need a label on so I know that it's a degree and not a side length. So A over here is 40.1. But I don't need to do that again just to find this other side. We do the same thing we did before. 180 minus 40.1 minus 75. We get 64.9. And I could write that down. In fact, I will. I'll say B equals 64.9 just so we have a record of it. But I'm not quite finished. I have to do one more law of sines in order to find this side. So I'm going to set up my true pair again with sine of 75 over 3 equal to sine of what I just found out. I just found out that that was 64.9, and it pairs with my unknown. We throw that into a calculator. And we get this. Oh, nope, I didn't close my sine when I started out, so let me go back and fix that. Sine of 64.9, close parenthesis, times 3 divided by sine of 75. There we go. Got to close that parenthesis. And I get 2.8, which is much more accurate. Even I make mistakes. There we go. 2.8. When do we use this? Well, we have two cases. We have when we're trying to find the angles and when we're trying to find the sides there. So this triangle started out originally as what? An angle, angle, side. And, or the, I believe it is an SAS, yeah. So this would be angle, side angle, which we have. Because once we found that other angle, we were good to go. All right, there is the law of sines for day 1. Let me know if you have any questions.